Wow. Well, we're going to go ahead and introduce you to the Sir Isaac Newton's definition of the derivative, and he did so using limits and using functions. So here is, this looks pretty intimidating. We'll go ahead and, of course, show you how this works out. It really is basic algebra, but we want to make sure that you're comfortable with this. So here is a formal definition of what we call a derivative. Now, of course, you've seen that functions have the notation f of x, correct? Well, now what we're proposing to you is that the derivative, or the slope in this case, the slope is going to be f prime x. So a little apostrophe in between those two, that's prime. That would be like the first derivative. If we have double prime, that would be the second derivative, and so forth. Okay, so that is f prime x, which indicates a slope or a derivative. In this case, we are doing the definition of the derivative or the slope by Newton. There's a rich history about calculus and how it was developed at the same time by two different people individually. We had Sir Isaac Newton and we had Gottfried Leibniz. And so Leibniz, for example, Newton was the one doing primes, and then Leibniz, he was practical. He had a dot on top of it. So that would be this is the same idea, just different notation. Okay, so what this is saying is, okay, we want to take a derivative or the slope of find the slope of a tangent line of a graph. We're going to find the limit, and we're going to take the original function and do the hokey pokey with it. We're going to introduce another letter, as if we didn't have enough letters to deal with. Okay, so technically we're going to give you a point, but we're not going to use that point right now at all. Your calculus teacher will use that point to actually come up with the equation of the tangent line. Okay, now what we're talking about here is, for example, if I have a graph and let's say I have a point right here at 1, 5, then we'd be interested in the tangent line at that point. Okay, this has a lot of applications in many fields, but we're going to keep this simple for now. We're not going to even find the equation necessarily of the line. All we're going to do is find the slope of the line. Okay, so we'll start with, of course, a, and we have f of x equals 2x plus 3. So what Newton's going to ask us to do is the following. If we want to find f prime, we got to set up the limit as x approaches 0 of f of x plus h minus f of x over h. So for example, let's go ahead and begin with the easy part, right? There's a minus, there's an h in the bottom, which nothing we can do about that. F of x is 2x plus 3. May I suggest put in parentheses? Okay, so the formula itself is asking for f of x in there, so I'm going to put f of x, which in this case is 2x plus 3. However, in the beginning part of the numerator, it says f parenthesis x plus h. So what this is asking you to do is wherever you have an x in the original problem, you're going to substitute that with x plus h. Okay, so what we have now is a 2 plus a 3, but it's not an x, it's an x plus h. I vividly remember doing these problems and being stuck on them and working on them. At the time I was taking Music 131 at AVC, and I remember being waiting for my class to begin in the music building, and I was just doing these problems and I was frustrated and I was like, what the heck is going on? This makes no sense. Okay, so I'm teaching you from experience so that you don't have the same bewilderment as I did. Okay, so we are replacing this x with x plus h. That's what's happening here. Okay, if we distribute this, and of course, this minus gets distributed as well. This is very crucial. There's a lot of opportunity for mistakes here, algebra mistakes. So have your A game algebra. Have your A game algebra. Have your algebra A game on. Okay. Otherwise, you're not gonna have a pre-calculus A game right now. Okay. And then just combine like terms. Notice there's 2x and this minus 2x. Those cancel out. And we happen to also have this plus 3 and this minus 3 that also cancel out. So what I'm left with at the end is limit as x approaches 0 of 2h over h. But again, these h's cancel out. And there's nowhere to put in a 0. And so this is as we did before with problem 8 on the other video. We end up getting that the limit is simply 2 for this problem. All that craziness just for a little itty bitty 2. May I suggest that you try out part B? Same idea, right? The h is general. You just put the h in the bottom automatically. You make sure you copy the function f of x to the right of the minus. Don't forget to put in parentheses so you can distribute it. And then you're gonna, instead of when you put it in the beginning of the numerator, instead of the x, you're gonna put x plus h in parentheses for that for x plus 2. Okay, try that out. Part C is beefy. It's a nice one. It's a very nice one. So here we are, right? If it helps you this time around, let me go ahead and show you what f of x plus h is going to look like. This might help you out with some headaches. So that means wherever I have an x, I'm going to put x plus h. And to help you see better, I went ahead and replaced them, right? Because this set of parentheses represents the x squared, and then this is the x. And what I did is I replaced this x with x plus h, and this x with x plus h. And so we have this right here. I'm going to go ahead and distribute. This is going to be x plus h times x plus h. And if we distribute that, we're going to get x squared plus 2xh plus h squared. And then on the other end, I have this, over here I have x plus h. And then if I combine like terms or do whatever I can, well, to be honest, there isn't anything to combine. So that is our fx plus h. Okay, this whole entire pink thing right here. Setting up the definition using the limit, I have x squared plus 2xh plus h squared plus x plus h. There's an h in the bottom automatically. There's a minus. And I'm supposed to put the original function in here. The original function was x squared plus x. If I distribute that negative to both of these, we get a negative x squared minus x. At this point, some magical things happen. You have this x squared and this minus x squared. They cancel out. You have this positive x and this minus x. These cancel out. We are left with limit as h approaches 0 of 2xh plus h squared plus h over h. We can factor. Remember, these kinds of problems, calculus requires you to have, like I said, algebra A game. You must be comfortable pumping these things out pretty fast. So if you look at your numerator, for example, they all have a common h. I'm going to factor out a common h from all three terms in the numerator. That leaves me a 2x, a plus h, and a plus 1. And there's an h on the bottom. These h's cancel out. And this results in me simply putting in a 0 for h. That gives me 2x plus 1 as the answer. This time we have a variable in there. If you're concerned about the x being there, no big deal, because the limit was looking at h approaching 0. It said nothing about the x. Okay. This, in a weird turn of events, ends up being the equation for the slope of the tangent line. Now you notice, of course, that in each case I gave you points, right? Again, your calculus teacher will go deeper into that. That's going to be used for finding the full equation of the entire equation of the tangent line. Right now, what we're finding are slopes or the equations of the slopes. We could technically find the slope if we go ahead and were to plug in, of course, the values given to us in the respective points. We're not going to do that in this class. My goal is to focus on the limits, literally, of limits, and what they're used for and how they are incorporated into helping to find the slopes or the derivatives in this case. Okay. I would love for you to try out D. Hopefully it goes well for you. You should get an answer on this one that should be 2x minus 1. So good luck with that one.